Hello everyone. Now in this video we are going to see the one more tutorial of how to convert orthographic to isometric solid. In the previous tutorials we discussed so many examples, and this example is quite different from the previous one, and while the construction you will come to know what is the main difference. You can see that this is the front view and top view of a iso solid. Okay, using these two we need to construct. Yes, so the moment we see the question, immediately draw the projectors from each and every segment to identify how many number of parts are there to construct in the AutoCAD 3D layout. If you observe carefully, this is a complete profile, different profile, which is of this part number 1. This part is completely 1, and a circular hole in this base, this is completely a second part. So second is drilled in the base. Okay, and now in the top view, if you observe, this is the difficult profile, complicated profile. The part is 3, which is of having height 70 mm with some taperedness. So from this we understood that there is 3 parts in this diagram. So based on these 3 we are going to construct. As I said in the previous tutorial also, to construct we always have to look at the true profile. In the front view it looks like a rectangle. With the rectangle and lines we can't do the construction. So always start with the true profile. So you know that this complete length is 60, but here they gave the radius is 30. From this we can understood that this arc, the outer one, is the radius 30 and this is 60. What about this distance? So we are having some more distance is 15 plus 15. So 60 minus 30 equals to, this is 30. So 30, and from here 30, because radius is 30. And using this one I am going to construct this profile in the AutoCAD. So this is the 3D modeling layout. So to construct, go for the southwest isometric. Now take the line 30, 30, okay, and now using this center I am constructing. Go to the top view and then again southwest isometric, circle, circle, 30. Now draw quadrant 30, and this is 60, you know. So we don't want this semicircular portion. Trim, TR, double enter, cut these two. Okay, again with the same center we are having one more circle of radius 15, nothing but dia 30. So take the circle, radius 15. Okay, we finish this one, second one, and now we don't require this construction line. So I am forming a single segment of part 1 using the command join. Join. Okay, we form the plane. So as a solid, this profile base height is 15. In the front view you can see the height 15, as well as throughout this base a circular hole is there. So this height is also 15. So that's why I am selecting these two, 1, 2, and I am using extrude command. Height is 15. Perfect. Yes, now we formed this one. If you want to see, we can see in the realistic. See, this part 2 is in part 1. Okay, now I need to make a hole in this one. So what I am going to do is that, using the subtract command, select solid surfaces and regions to subtract from, enter. Now to subtract, enter, enter. See, we formed this part. So we finished this one, and now we have to construct this one, this profile. As we know that this length is 30, 60 minus 30, this is 30, and this is 20, 30, and then 20. So now I am going to do 60, 30, 20. Line 30, 20. Yes, we formed this one, and now we have to connect this one from here to here, here to here. This line is 40 mm exactly from the center. From the center, above 20, below 20, and the gap between these two is 15. So what I am going to do is that from the middle 15, okay, and now this length is 40, above is 20, stretch 20, perfectly we finished, and we don't require this one, delete it. And now join from here to here, join exactly to the end, take the line from here to here. Okay, now we form this one, and we are making it as a single one using the join command. Okay, now in the front view you can see that this profile height is 70 mm. Profile height is 70 mm. So now I am extruding the height as 70 mm. Perfectly finished, 70 mm. Okay, now if you see, this point should merge with this point combination. So now select, move, this is the base point, and from here to here I am moving it perfectly, we faced it. Okay, see, these two parts we finished. So now I am making it a single one, because it's a composite solid. Union, enter, select objects, enter, finished. Okay, now after forming this one, you can see the main difference. As I said earlier, this is generally in the previous tutorials we extruded the simply 70 mm, but here the extrusion is of taperedness. The height is 70 from here, and from here some height, we need to calculate that one. See, from the top 15 and here 15, total 70 minus 30, this distance will be 40. So now from 40 to 70 there will be taperedness, so we need to remove this space. Trim won't work here, so we need to use a tool called slicing. This is the quite different tool we are using in this one compared to the previous tutorial, slice. The slice tool already we used in the tutorial of hemisphere, how to draw the isometric view of a hemisphere. There we used the slice. The same command I am going to use here. So now I am changing it to front view. I am going for the 2D wireframe. Okay, as I said, this is 70 from top 15, bottom 15. Now from here 40, and then it will connect here. Draw a line 40, and from here you can connect it. And now go to the southwest isometric. Okay, just I am moving from here to here. Front, take the line, this is the end point. From here you can connect here, go to the southwest isometric. Okay, not this one, from here. Okay, we finished this one, 40 to 50. Okay, and now we need to remove this portion. Use the tool slice, enter. So this is the object we need to slice. Select the object to slice, select, enter. Now it is asking specify starting point of slicing plane from here and from to here. Just press enter. See, it slices. You can't see in the realistic. Just click it here. You can move it. See, we cut this portion and we don't require this one. Select this one, delete. That's it. See, now we form successfully this one. You can have a orbital too. Perfectly we made it. So this is the one you can make using of slicing tool, Southwest Isometric. And now to get this one in the layout, okay, just click on paper, use the pan command, move it aside, switch off the grid, okay, base, model space. Okay, before importing this one, as I said in the previous tutorial also, check out drafting standard setup. Always it should be in first angle projection, not in third angle. Check it out on first angle projection. Okay, and then go to the base, model space, click it here, enter this one and this one, enter. As already we know the orthographic not required, so that's why I am deleting it and just moving it to the center. If you want to make it the bigger scale, already 1:1 is there, so I am making it as 1.5:1, a bigger one. Yeah, okay. So now I can increase this box height also. This is the space layout. Okay, see, now clearly you can see the invisible lines and visible lines. If you want to hide the invisible lines, double click on it, hidden lines, only visible lines you can see. Hidden lines shaded with visible lines you can see. Hidden lines shaded with visible and hidden lines, but always I prefer to be visible and hidden lines in the wireframe model. Okay, now we finish this one. To give some line thickness, already some thickness will be there. Type LWD, enter, ON, on. See, we got the line thickness. Okay, so if you want to change the color of the line, click on layer properties, visible line, you can make it as a red or any other color. Okay, see, it finished. If you want to change the hidden line, you can make it as a blue. Yeah, now it changes. To close this one, again press on the layer properties, finished. Now we need to give the dimension, DAL, from here to here. And then this height, dimension of this one will give later. Okay, and this height. Okay, yeah, so we give, and also this dimension will give. Okay, yeah, and this one is the remaining one. Okay, yeah, so we can change the text, annotate, standard right, manage textiles times New Roman, apply, close. Yeah, perfectly we made it. As I already discussed in the previous tutorial, here actual height is 15 mm and this is 60 mm, because based on the isometric scale and the scale we enlarged, the dimension got changed. So we can change this one using two ways. So first I am opening the calculator, enter. Here see, this is the 60 mm, right, but we got 48.99. 60 divided by 48.99 equals to, so we got 1.2247 factor. So to change this scale, DST, enter, modify, primary units, here measurement scale, scale factor 1.224739. okay, apply to layout dimensions only, you can click OK, close. See, we got 60, 15, this is actually 30, perfectly 60, and this should be 50. We'll give once again, we got 40, 20, perfect dimension. Actually this is 40. Sometimes based on the scale factor it will change, so that's why you double click it. 40, 70 is there, dimension aligned. Okay, we'll close this calculator. DAL, yeah, this is 20, because of scale it changed. 20, sorry, it's 15. Yeah, now we have to give the dimension for this radius and this radius. As you know, to give the dimension we need to go for the command mleader, okay, mleader, multi-leader. So specify the arrowhead, this radius or dia 30. The size is very small, text size. So go to the annotate and leaders, modify, content, text height is 0.18 is here, I am changing it as 0.5, leader format, arrow size head is 0.18, I am changing it as 3, okay, close. See, now we got this dia as 30. Again type mleader, enter, and now this is the arrowhead, dia 60, perfect. This dia is 60 and this dia is 30. And now the final step is that to make this dimension parallel to the isoplane, dimension edit, /O, enter. So this one should be parallel to this plane. So I selected these two, enter, obliquing angle, yeah, I made it. And now this 70 dimension, this 50 dimension should be parallel to this plane. So DED, enter, oblique, dimension 1, dimension 2, dimension, okay, these two will go for this one, perfect, 70 and 50, and this one already 20, it's perfect, which is parallel to this one. Yeah, now this one will make in this plane, edit, oblique, select this one, will make, perfect. Yes, so now everything we finished perfectly. So as I said in the previous tutorial, these are the reassociate dimensions. To overcome this one, just click on the paper, it will disappear, that's it. So now take the line, click on the model, okay, DAN angular. We need to give the angle between these two lines. This represents the isometric view. Actually line is not here, that's why it is not taking. Okay, 30 degrees we completed. So this is perfect way of representation of a ortho to iso solid. Just click on paper to make this one disappear. Perfect. Now we can export this one into the PDF. Control